for one of the reasons for us asking you to put your location on is so that, it clearly demonstrates the wide reach of this group, which Zoom makes possible. Marion, I'm just wondering where you are. You're on mute, Marion. Oh, forget, you're still on mute. Never mind. So as I was saying, welcome to Steve, who's a new member. I don't know if we've got any other new members here. Have you, Ellie, have you spotted? No?
No, I haven't actually.
We had a meeting for new members yesterday. We do that, Ellie and I, and sometimes Mary do that regularly, just so that new members can have a bit more information, about how this group works. And it just helps people to feel a bit more comfortable when they join, a large meeting like this. Now I'm going to hand over to Ellie to give us some updates.
Right, greetings everybody. The first thing that we want to do is to just give you a little bit of feedback on our summer school that we're all back from, and I'm hoping mostly recovered from. So I'm hoping you can now see my screen.
Yep.
So this is what it looked like in Warwick University. We chose Warwick, A, because it was fairly central for the country and it was near a different set of people to the previous summer school, which was in North Wales. It was more comfortable than the previous one. You can see the rooms there, little courtyard for coffees. It was a very it was a business centre and it was like hotel quality. On the way, for those who could get there, while some of us were still travelling, we went to visit a recycling plant, which was where the stuff out of your recycling bin goes. So they were sorting paper, card, glass, tin, etc. So that was very interesting. We made use of the university facilities, and here we have a lady who's a sustainability officer at Warwick University. So she gave us a little biodiversity tour and created through using wildflower turf, which is a quick and easy way to get your wildflowers on. We had lots of talks and different members of our planning team introduced people. So there we can see Anne introducing David, who's going to be our speaker later on today, about a talk about anaerobic digestion, which is what happens, that's how our food waste is being processed in lots of areas. We had an icebreaker on the first night, inviting us to share something from home. And one of our members brought an abalone shell and talked about how the acidity of the sea is stopping mollusks from making their shells. And another member is not that little cat there, but the picture is there to remind us that we don't need to have our houses necessarily as hot. When you feel cold, you can go and put your jumper on.
And on your cat.
Yeah, the first night was a bit scuppered because our dinner took a lot longer than we expected. So that really annoyed me because I like it to run smoothly, but we got it sorted for the other nights. We talked about different books we'd read, different films we'd seen, and objects that are useful. And Nick Ward has collected all of that information to update our website with it. So there's a direct link into our website. We had quite a few focuses on Stratford, which is a local town, and they have a climate hub. So we had Stephen Norrie speaking to us, who was very enthusiastic and brought a wonderful perspective. We had Keith Richards, who came to speak to us following problem in the net zero hub that Janet Palmer there was telling us about, where somebody aggressive came in and started arguing. And Keith did a lovely bit of work on telling us how to de-escalate if you get into a climate argument. And the basis is listen well and don't try to make your point. We had a game called Fresque, which was very interesting. So you're given a set of cards and you're giving them in a few at a time. Then you have to make a huge web from them about what causes what. You can see all the pencils there showing causality. We had 3 people helping to run the session that came in to help us. And it was very interesting. I hadn't realised that every leader runs this game in a slightly different way. But it's something I would definitely do again. And there's our very own Nick Ward talking about the website. And he ran a session for us too. The grounds were part of the experience. It was really beautiful. You can see a heron in the front of the picture with the water. And there were artworks around the site as well that were quite interesting to go and see. There's 2 of our participants just enjoying a little coffee between sessions. I think Warwick University is the place that I've been to that's got the most real sustainability sort of lived out. So even in the bins, you were able to sort your waste there. We had a visit from the chair of the U3A nationally, Alan Walmsley. So that was very nice that he came to see us. And he was particularly interested in this electricity talk we had, which was really helpful in explaining all the different numbers and letters used in our electricity and where it comes from. And then on the very last day, on the way home, we had a visit to a solar farm. So in Wales, we did a wind farm, and now we've done a solar farm. And the feedback on that, well, Anne will give you the feedback later, but people enjoyed that too. And there we all are. Everybody was happy to have their photo taken. And yeah, Anne's just got some little feedback for us, telling us what did people think.
Yeah, thank you. Thank you for all your feedback. There was a lot of detail, lots of useful information, and it will be really useful for planning another summer school sometime, whenever. I mean, on the first category, what you liked about it, what they liked is mainly, I mean, a lot to do with meeting like-minded and friendly people. One person even put delightful people, which I thought was rather nice of them, and forming new friendships and networking. So that was mentioned a lot. And they also like the quality and the variety of the content. Climate Fresh got a lot of mentions, enjoyable and useful. The films, Water Bear, were popular. And actually, the item from home session seemed very popular as well. So the lectures, the biodiversity walk, and the site visits, particularly to the recycling centre, well, and solar farm, they were highlighted as intellectually stimulating and engaging, all the content. So that was good. The venue obviously got a good write-up, accommodation and were lovely. The campus very green and leafy. Loved the nature walk. And they thought it was all very well organized. One person put a mentally invigorating experience. There were several people said something like that, using the old grey cells, dusting them off, and so on. Yeah. Top takeaways was another category. So attendees were impressed by what can actually be done by local action. We had several speakers on that. So the Stratford Climate Hub, Harbury Future Energy Project, and the Climate Action in Warwickshire. So they were really impressed and, you know, maybe went away thinking that they could do something similar.
Okay.
Many highlighted a deeper understanding of climate issues. I should imagine Climate Fresk had quite a lot to do with that. And the de-escalation techniques was popular. participants came away feeling they weren't alone in their climate concerns, and they were determined to stay positive and engaged. And they were starting to think about how to start local conversations and raise awareness, but not in a non-judgmental way. Okay, so I think maybe the de-escalation techniques and the Stratford Climate Hub talk gave them some ideas on that. So to make it even better, some people wanted even more hands-on sessions, more group interaction, maybe some small group work like we do here with the breakout rooms, maybe something like that. And some felt, a few felt a lower cost to make it more accessible, more inclusive. Some felt there should be women speakers on scientific and technical aspects. We should endeavour to get women speakers that could speak on those aspects. More games, more quizzes, more site visits. I mean, we did too. I mean, I mean, so summary of suggested future locations. Well, there were plenty of suggestions. Scotland, including Glasgow, Edinburgh, New Lanark, Northern England, several of the universities mentioned, Midlands again, because it's central, London, because it's easily accessible for lots of people, a greener city like Brighton, the type of venue, again, university, or maybe a field centre, okay? Maybe that wouldn't be quite as comfortable, but it might certainly be a little cheaper. So plenty of ideas for content and speakers. Several mentions of the Reform Party came up, who had just been very successful in the local elections. So we were thinking of, they came up, they had the idea, maybe strategies to engage with disengaged or right-leaning audiences and the disinterested, which I think is important. The other ideas, there were loads of them. The global perspective, the Green New Deal, what to say to your MP, alternatives to capitalism, heat pumps, carbon sequestration, nuclear fusion, battery technology, green cement, nature conservation, global justice. So ideas for speakers. Well, there weren't very many ideas.
I think I'm actually just going to stop you there just because we're running out of time a little bit. Is that all right? Thank you so much for doing that. It gave us a really nice flavour for what people thought.
I hadn't really finished anyway.
I'm going to hand over to Terry because if you've been missing each other, there's another chance to meet up coming shortly.
Yes. So I recently relocated from England to Scotland, and I'm trying to find out what goes on in the green sphere in Scotland, and obviously join the U3As and get the U3A emails, and recently discovered that they're planning to have a festival, a jamboree on the 29th of August in Edinburgh. So I thought I would not be a wimp and say, no, it's all too much effort. Especially in view of what happened to poor Blatton a couple of days ago. We were going there in a couple of weeks. We know the place well and we love it. Sorry.
So what Terry wants, I know Terry, that's very close to your heart, isn't it? If anybody is interested in going to the Scottish Jamboree in Edinburgh on the 29th of August, do make contact and we pass your details on to Terry, who's organising it. So we'll have some workshops for people and a stall, we're hoping. Sorry, Terry, hope you're okay there. And again, in September, we thought we'd have just a meet-up in Oxford for anybody who can get there just for a day or who wants to make a few days of a personal holiday there. The details are to follow, but we're thinking of having a walk along the canal, something like that, lunch and then afternoon tea. And Jenny, would you like to mention the York Festival?
Yes, thank you. 2 years ago, is it 2 years ago or last year? We were at the National U3A York Festival and we ran 2 workshops and we had a stall there for the 3 days. And we had a terrific response. We had lots of leaflets and things to hand out to people. We had a great location, so there was good footfall. Anyway, the Trust have decided to run another event next year. They've chosen York again because it's central. The university is very obliging. The dates haven't been set yet, but as soon as they are, we're going to put in an application to be involved to, offer probably again a stall and workshops because it worked really well. So as soon as we know any more about that, we'll let you know. Is that okay, Ellie?
That's perfect. And we're going to hand over to Ian next, who's going to bring us our monthly news.
Right, thank you very much. I'll just screen share. Yes, a few items that I've picked up for this month. There's quite a nice announcement from the government about UK solar panels. UK government announced that almost all new homes will be fitted with solar panels within the next couple of years. Exactly how they're going to do that, what the details were, was not entirely clear, but certainly new build houses, we can expect to see a large proportion of them come with solar panels. The additional cost for a semi is about £3,000, which is, I mean, for my house, I paid £12,000 on solar panels, so that's cheap, that's good, because they put in while the house is being built, which is a much better way of rather than retrofitting. A new householder should be able to recoup the extra cost within about 3 to 4 years, or 4 to 5 years. So I think that was a bit of good news on solar panels being encouraged by the government. Just a bit on the global side, forest fires, as we know, have increased. The Nature, Ecological and Evolution have published a report giving some numbers. Big forest increases in North America, Siberia, Europe and Australia. And these are being monitored via satellite observations, so we can monitor them exactly every day and how they spread and so on and so forth. And this is what's going to happen with global warming. You get these more extremes of weather and the forest gets dry and it catches alight. So that's probably going to get worse, but we do need to think about how we can manage that situation. And also the forests are taking longer to recover, in a warmer climate. If there's less rainfall, they take longer to recover. Geoengineering projects, which is something you hear about occasionally, which is about fixing the planet once we've trashed it. How do we fix it? These are long-term projects. One method is to suck out all the CO2 by doing this on a massive scale. It'll still probably take 200 or 300 years to do. Or you can block out the sun by various methods, which is actually quite a lot faster. Anyway, the government has set up some projects, £60 million into university projects to explore options for geoengineering. So this is a bit of a change in thinking. I think they're getting to the stage where they're thinking, well, we can't stop global warming, so how are we going to fix the planet? Okay. Global temperature rise, as we know, it's increasing. Expected to rise close to 2 degrees centigrade average above pre-industrial levels in 5 years or so. So by the end of the decade, they're predicting, that's the World Meteorological Organization, is predicting a 2 degree rise, which is well above 1.5. I mean, 1.5 is totally dead as far as I'm concerned. The next milestone is 2 degrees. So we're currently on track to reach that by end of the decade, 2030, which is not good news. UK wind power, some good news here. The government's going ahead and ramping up the UK wind power, offshore and onshore. So we'll have 3 times the amount offshore and twice the amount onshore. Now they've lifted the ban on putting wind farms onshore. The main issue, as far as the suppliers is concerned, is setting the strike price at a sufficiently high level to encourage them to bid. This is the money that they get back from the wind power, having made their investment. So last year, this was far too low. There are very few bids, so the government needs to get a realistic strike price. But that's all going ahead, and that is good. And the plan is to get to 95% green energy by 2030. Ed Miliband said this. I think that is optimistic, to be honest. But if he can get to 85, 90%, that will be a major step forward. So again, that's quite good news. China seems to have reached peak emissions, which I was pleased to see. On the last months, the CO2 emissions seem to be coming down, which is good news. Hopefully they'll stay down. They were down by 1.6% in the first part of the year, and by 1% over the last 12 months. So that is good news. China's putting massive amounts into renewable energy, mainly solar and wind, because they've got so much space, Western China, so they're just putting in lots of green energy. And the problem they've got is actually transporting it back to the coastal areas. So they're having to upgrade their national grid at the same time. But anyway, that was good news for China. Climate adaptation planning has always lagged behind and been insufficient. So we are saying that the climate is going to change. We need to adapt our cities. In Europe, nearly half the 327 cities have not published yet an adaptation plan for climate change. Of the 167 that have published a plan, they're fairly random. They're not coordinated. So there doesn't seem to be an overall plan for adaptation, even where it's going in. For example, 81 plans said there was a risk of increasing storms and winds, but didn't have an adaptation plan for what to do about it. So adaptation is really something which really needs to move ahead. I wrote to the CCC about this, and they said, yes, it's lagging behind, even in the UK. So that's something we need to fix. And finally, UK drought. We all experienced a drought the last couple of months, especially in northwest England. So there has been some rain the last couple of days, but we're finding the reservoirs are at record lows. So the government is planning to build another 3 reservoirs by 2030, mainly Lincolnshire and East Anglia, and they've got plans in offering about another 12 or so, going up to about up to the middle of the century. So the government is aware of this problem of drought. Southeast England is going to be hit hardest because that's where most of the population is. So and so on, and the Thames water saga. So Southeast England really needs quite a bit of work on it. But anyway, the government is taking a look at this. Okay, those were the main things that I picked up for this month. Thank you.
Thank you, Ian.
I think we do have some time for Ian, if there are any
Please.
questions.
Questions rather than comments. Idris, is that your hand up? You're on mute. You need to unmute, Idris. Can't hear you.
Oh, never mind. I can't do lip reading. Yeah.
Anybody else got a comment? Heather, you're muted. All right, you're unmuted.
Yeah, a question on the geoengineering. I thought the whole thing with geoengineering was to change the entire sort of climate of the planet. So how can you do a small scale experiment on geoengineering?
Yeah, that's a good point. I mean, they're sponsoring some university projects, 60 million. I think they're going to look at cloud brightening, putting stuff into the clouds, for cloud formation to reflect energy back into space. And there's obviously research in terms of ways of scaling up how we extract carbon from the atmosphere. One interesting idea was to actually extract carbon from the sea, because the concentration of carbon in the sea is 300 times higher than it is in the atmosphere. So it's much easier to get carbon out of the sea. And then the carbon will then absorb carbon, the carbon from the atmosphere. So that was an interesting project that they were sponsoring. So it does need some new thinking, but the whole thing is about scalability and so on. But it was just interesting that they've suddenly started these projects up. So it's a kind of recognition that we may not be able to mitigate. We do need to adapt, and we probably need to geoengineer.
Thank you.
Thank you, Ian. Joe?
Is there any chance of getting the government to reprice electricity and make it more fairly priced, which would, I think, lead to a lot more acceptance of all the wind farms and electric cars and heat pumps and everything based on electricity, which right now it seems to be unfairly highly priced?
Yeah, this seems to be the commercial arrangements that they have, so the most expensive source actually sets the price, which is North Sea gas, which is absolutely crazy. Why they can't just change that? They had a meeting and tried to change it about 6 months ago, and nothing came. Their current plan is that if they can get to 95% green energy, the price will eventually come down anyway, because we'll become self-sufficient and we won't have to import expensive gas from overseas. So that's the kind of long-term plan. But I agree with you. I'm surprised that they can't do something straight away.
Because we have to write to our MPs, which is a first step.
Yeah, good idea. Yeah.
Okay, thanks.
David, you're muted, David.
Yeah, thanks. I just want to make a comment on this high electricity price. It's the highest in Europe. And actually, that's probably one of the reasons why we have the most wind farms in Europe, because it incentivizes the people building wind farms to get more money back from what they've invested in. If we had a low electricity price, we would have less wind farms. So there's a compromise, but I think the government has to face that somehow they can't have more and more wind farms without investing.
Thank you, David. Okay, Ellie, shall we move on through the agenda?
It's nearly time, but I see that Idris is now unmuted. If he
Okay, oh yeah.
Thank you. I was going to mention last week's report on landslip with a glacier eroding the natural habitat, I was going to say. We've no comment on that yet, have we?
No.
I think
glaciers are melting quickly. There'll be no summer polar ice by about 2035 or 2040. That'll disappear. I think that's irreversible at this stage. It hit a tipping point, and most of the glaciers probably hitting tipping points already, including the Himalayan glaciers. So yeah, it's a real issue, and it is going to alter the water flow from the rivers, and it's something where adaptation really needs to come in, and we need to store water, recognize the problem, increase the water storage, and manage the water supply a lot better globally.
Irrigation in those parts of the world has been largely dependent on spring flow, hasn't it?
Yes, and the spring flow, what they're going to find is that the water coming from say the Himalayas, if there's no glaciers, you'll suddenly get a mass of water during the monsoon, and then you'll have 6 months where there's nothing. So the agricultural system, they've got to store the water. They've got to store it. There's no other way around it.
Right, we're just going to Catherine for the last question. If you unmute, please, Catherine.
Meanwhile, we are surrounded by political systems around the world which are throwing net zero out of the window as fast as they can and are working against any of the good things that we hear about. And I do find it, I can't but be quite depressed about that. Sorry to say that to everybody, but it's reality, I'm afraid, at the moment.
Thank you. Right, I'm going to move on to our main part of the meeting and introduce our speaker, David. Can I just remind you, while David is giving his presentation, to not put things in the chat because it's very distracting, and keep yourself on mute so that we can all, be focused. I would just like to say we are extremely grateful to David because the person who was booked to speak to us today let us down, and we asked David if he could help us out, and he immediately agreed and had a number of suggestions. So thank you very much, David. I've got David's summary here, and I'm just in absolute total gobsmacked awe. Are you ready for this? David is a graduate of St Andrews University with a degree in chemistry and biochemistry. He's worked in 3 sectors in the energy industries. He trained as an oil and gas well service engineer. He's worked in the team at Texaco Europe, planning refinery production runs and ship movements. He was the energy products market manager with Dow Corning Europe. David has been a consultant to the European Commission, helping to write a directive on the disposal of toxic waste. He's managed his company Lion Industries for 25 years, which he brought to Lichfield in 1988, where he currently lives with his wife, Barbara. David has been a Lichfield City Councillor for 20 years, and he was Governor of Burton Hospital for 7 years. He's an associate of the Royal Society of Chemistry and a fellow and executive of the Lunar Society in Birmingham, where he leads their Climate Change Working Party, which is helping Birmingham City Council decarbonise the city. He's a member of the U3A Trust COP27 group and the U3A Climate Change Advisors. David, when do you get time to sleep?
Not much.
So David is going to speak to us about hydrogen, and when he's finished, we'll have time for a few questions, and then we'll go into breakout rooms to discuss this. So with thinking that in the breakout rooms, we will be talking about things like the benefits of using hydrogen, where is it of most use, what methods are making hydrogen the best, and is it ethical to be using hydrogen or ammonia from Africa and the Middle East? Is this, like an old colonial type mindset? So thank you very, very much, David. Over to you.
Thank you. So can you all see that?
Yes.
Right, there's the question. Let me just reduce the size of this a little bit off the screen.
It's fine.
Right, so why hydrogen? So I start out with explaining the hydrogen molecule. It is the smallest molecule in the elements. It's what powers the sun, as you'll see in a minute. It consists of the hydrogen atom, which is a proton. That's a positively charged particle in the middle of the atom, an electron whizzing round. And what's important to see here is this electron goes round and round and round, and it has to go so fast so the centripetal force prevents it from collapsing in on the proton in the middle. So that electron moves at the highest speed of all the electrons in the periodic table of the elements. So here's an interesting thought. Ever since man discovered fire, we've actually been burning hydrogen. So the question then is, how's that? And the answer is it's carried on the back of a chain of carbon atoms. So here's an example. So all the fossil fuels, the oil and gas that we use, they're all hydrogen carriers. They're hydrocarbons. And if you look at the little diagram there, you can see the black carbon atoms form a chain. In this particular case, this is pentane. It's a molecule with, because of the pentane, 5 carbon atoms, and you've got 12 hydrogen atoms around it. So that is a carrier of hydrogen. The hydrogen strategy, which was published in August 2021, predicts that in the UK, the hydrogen demand proportion of our total energy could reach 35% by 2050, even could be a bit more. And when you think that our electricity demand, all of our electricity, is only 20% of our annual energy demand, how is it that hydrogen is going to be like 50% more of that by 2050? So I hope we shall explain that here. So we need hydrogen to power vehicles. On the left is a Toyota Mirai here. I've had a ride in a Toyota Mirai, which is hydrogen powered, both here in Birmingham, but also down in London. I was able once to have a ride in a hydrogen powered taxi, and I've driven the Toyota Mirai of my friend who has one in Birmingham up here in Lichfield. When it comes to heavy duty vehicles, you've got the refuse truck here on the left. You'll see later in this presentation, these are already being powered by hydrogen in some parts. There's the bus that are actually operating in Birmingham. There are 20 of them, have been working for several years. They're all powered by hydrogen. But you can also use hydrogen to store energy. For example, wind farms that have too much energy during the day, they can store the energy as hydrogen. It's not as efficient as batteries, but it has other advantages. Green steel production at SSAB in Sweden, instead of using coke to remove the oxygen from the iron ore, you can use hydrogen. So, hydrogen, most abundant element in the universe. It powers the sun and the stars, and it does this by fusing hydrogen atoms together. That's fusion, nuclear fusion, which is a separate subject on its own, which we could talk about as a separate presentation. There's the sun, as you're probably familiar with that kind of picture. What's interesting is it burns, that is to say it fuses around about 660 million tons of hydrogen every second, which is amazing. Anyway, on Earth, we can't do that because the temperature is in the multiple millions of degrees, something like 20 million degrees in the sun. So here on Earth, we use the chemical reaction of hydrogen joining with oxygen from the air to make water. That releases a large amount of energy as heat and light, or as heat and electricity. So the question is, going back to what I said earlier on, why is hydrogen such a powerful energy carrier? So building block of the elements, the tiny nucleus is positively charged, the electron negatively, and the electron has to keep itself from collapsing in on them, because obviously negative charges are attracted by positive charges, and it has to go extremely fast around the hydrogen nucleus. A bit similar to the planets in our solar system. These planets go round at a certain speed at a certain distance so that they don't collapse towards the attraction, the gravitational pull of the sun. So negatively charged electrons attracted to the positively charged nucleus, and in order to stop that, they must have an opposite centrifugal force, otherwise called a centripetal force. So when hydrogen is oxidized in air, which means joining it with the oxygen either by burning or with a fuel cell, hydrogen on the left, a molecule of hydrogen is two of these. They come together with one molecule, one atom of oxygen, produces water, oxygen, H2O, which you're probably familiar with. As you can see down below, hydrogen and oxygen becomes water, two lots of hydrogen plus oxygen, because it's a molecule, becomes 2 lots of water and lots of energy. And here's the key point. When you form 1 kilogram of water, you produce 8.86 kilowatt hours of energy. So here are some examples. When they combine, they release energy. So on the left, you've got heat energy is produced here by hydrogen joining with oxygen. This is an oxyhydrogen blow pipe. And on the right, you've got a fuel cell, which is typically put into a bus or some kind of heavy transport, which converts the hydrogen with oxygen from the air to produce electricity to drive the vehicle. So you have different sorts of hydrogen, but hydrogen doesn't have a color itself. But this is the way the industry characterizes it. The gray hydrogen is what comes typically from fossil fuels. There's a huge amount produced in this country, something like 1.5 million tons from converting methane into hydrogen and releasing huge amounts of carbon dioxide. So it's not very good for the environment, and it's called gray. I think it should be called black hydrogen, but that's another point. Blue hydrogen is gray hydrogen, where they've attempted to capture most of that carbon dioxide that's released in the process. But at the moment, it's only laboratory. It's not been done at scale. And all the oil companies in the United Kingdom are trying to develop a way of capturing the carbon dioxide so they can continue to use fossil methane. And then green hydrogen, that's what we get from renewable sources, electrolysis of water using wind power, solar power, nuclear power. So first of all, we need to make hydrogen. And the energy that's required to split water into hydrogen is the same as you remember before, 8.826 kilowatt hours per litre of hydrogen, in theory. On the right-hand side, you've got a schematic of an electrolyzer. And so what you have is the electricity from cathode and the anode draws the hydrogen out of the water across the membrane, and that comes out this side. So that's where we get our hydrogen. And in so doing, it produces water. Well, oxygen comes out here because you started out with H2O. Out comes the oxygen. So an electrolyzer uses water split with electricity into hydrogen and oxygen. These are commercial electrolyzers. This one on the right is truck mounted one. It's a skid mount. Basically, you can put it on the back of a vehicle and take it to where you need it. It's made by ITM Power, a British company, and it has an output, as you can see at the bottom, 270 kilograms of hydrogen a day. Now, 100% efficient, it would produce 1 kilogram of hydrogen with just 39 kilowatt hours. But these machines also give off heat because you've got a current passing. Therefore, they require a lot more electricity to produce it. And this German Clean Energy Partnership estimates that an electrolyzer of this type has an efficiency of around 60%. So you need 55 kilowatt hours to produce 1 kilogram of hydrogen. And to put that in perspective, the Toyota Mirai that I showed you in the previous picture, hydrogen powered car, it will run for about 400 miles on a full tank of 5.65 kilograms of hydrogen. That's the latest Mirai 2. And that requires 311 kilowatt hours to produce. So 311 kilowatt hours of electricity to drive that Toyota Mirai 400 miles. Now, the other way around, and that was what you find in the vehicles, you're going to use the hydrogen and oxygen from the air to produce electricity. So it's a reverse of the fuel cell that you saw before. Here comes in the hydrogen here. it goes through. This is the semi-permeable membrane, which only allows hydrogen ions to go through. The hydrogen molecule will not go through, but it's split with the electric current. Oxygen comes in here, and out comes the electric power. So this membrane currently is one produced by DuPont, and you can see it's a complicated chemical word, but it's PTFE membrane, just allows the hydrogen ions through. So let's sorry. This is how fuel cell works. Has the semi-permeable membrane in the middle. And as you can see, these are the way the electricity comes into it. They're all put together and compressed into a single cell. So the hydrogen comes in on the right, the air comes in on the left. So hydrogen comes in from the one side, oxygen from the air from the other side. The hydrogen loses its electrons, becoming a hydrogen ion. The electrons go around the circuit, join with the oxygen. Those hydrogen ions come through, join with the oxygen to form water. The water goes out, water vapor, with the nitrogen that came in as well. So we can carry hydrogen in various ways. Hydrocarbons on the left, typical examples, methane, ethane, propane. And we saw earlier on, we saw pentane, but you can also carry it on the back of nitrogen, which is important to know because it's a good way of transporting hydrogen in bulk. That's as ammonia. Hydrazine is a rather explosive material, so we wouldn't bother with that. And of course, here is the water molecule, and there's the hydrogen molecule. These are some examples of use of hydrogen. These bicycles powered by hydrogen in a very small tank exist. They were used at an international conference down in the south of France a few years ago. For all the delegates, they were given one of these to use. There's a prototype hydrogen-powered car from BMW. There is the Toyota Mirai at the Tyseley Energy Park, just south of Birmingham, sorry, just east of Birmingham, which I've had a ride in. This right bus here on the left has been operating in Aberdeen for many years, powered by hydrogen. Some other examples on the top left, this is Hydroflex. This is developed by Birmingham University in cooperation with one of the big rolling stock leasing companies in the country. I've actually had a ride in that one at the Energy Research Centre south of Stratford. On the right, you've got the Coradia Island, which has been operating and is still operating in many of the countries in Europe. In Germany, we'll see later on, there's a short video about it, in the Netherlands, in Austria, and in France. Bottom right, this is the hydrogen-powered refuse collection vehicle from Fawn Solar, who actually have a depot to the south of Birmingham. On the left-hand side, in the United States, Anheuser-Busch, the greatest manufacturer of beer and alcoholic drinks in the United States, they're using that to power some of their trucks. Ballard Motive, was Arcola Energy, has a hydrogen-powered refuse collection vehicle which is operating in Glasgow. So I'll just show you how that goes.
This electric bin lorry is powered by hydrogen gas. The advantage of hydrogen over plug-in batteries is it can deliver longer ranges, higher power, and can be refueled very quickly, with the only emission being clean water. This makes it a perfect solution for utility vehicles that are working long, hard shifts without breaks for recharging. But this isn't a technology demonstrator, it's a fully production-ready prototype that will become the blueprint for a fleet of 20 that will soon be in service with Glasgow City Council. But how does it work?
On the roof, you can see the hydrogen storage. The filling point here is where the hydrogen goes in. Under the cab, we have the fuel cell, which turns the hydrogen into electricity. Underneath the fuel cell, we've packaged batteries, which provide the power to drive the wheels and the rest of the equipment. Along the side here, we've got the equipment which drives the bin body and the brakes. And then in the center here, we've got the power electronics and other systems that make it all hang together.
The production of this vehicle and the sale to Glasgow City Council are a direct consequence of a research project part funded by the Advanced Propulsion Centre to find the best business case for heavy-duty hydrogen fuel cell vehicles. This use case works so well because bin lorries work long, hard shifts and always come back to the same depot where they can refuel with hydrogen. The project has had a number of tangible economic benefits.
We've got a much clearer direction as a business, actually, in terms of what we're doing. We've got customers lined up. There's a whole bunch of people who would like one of these and other vehicles that they're asking us for that align with the capabilities of the tech. And we're looking at this site here in Dundee, 150 people in the next couple of years to do the production, the assembly, further integration and engineering of these sorts of vehicles for customers.
The issue for heavy-duty battery electric vehicles is running one or two is easy, but if you want to run a fleet, you'll need a massive upgrade to the electricity infrastructure to charge them. Hydrogen electric fleets can scale more easily.
You can do one or two vehicles really easy with battery electric, but once you get up to the 50, 100, it's a lot of energy, and suddenly looking at infrastructure upgrades. Hydrogen, kind of the minimum is 20 vehicles. That justifies a refueler, but once you've got that refueler, it scales much more quickly.
Once that hydrogen refueling infrastructure is in place, not only can you quickly and easily increase your hydrogen-powered fleet, but it can then also be used to fuel other heavy-duty fleet, such as long-distance HGVs, construction and farm machinery. If we can create a demand for hydrogen for transport, it means we can also improve the business case for renewable energy projects that can produce green hydrogen whenever they're generating surplus electricity.
Renewable sites are looking for the stronger business case, and hydrogen plays a key role in that. So you've got centralized production of hydrogen at, say, a wind farm, and then moving that around as a milk round around several sites. So you've got then a pipeline of trucks delivering hydrogen to a number of refuelers, and you can start to see it scaling quite quickly.
So the hydrogen economy will deliver significant benefits when it gets to a certain scale. And projects like this one, enabled by Advanced Propulsion Centre funding, are helping to turn great ideas and world-leading technology into great business.
So before we move on to this one, just a comment. That video was made about 5 years ago. So there are hydrogen-powered refuse collection vehicles operating in Glasgow. So let's have a look at the train.
Radio Island is special for its combination of different innovative elements: a clean energy conversion, a flexible energy storage capacity, and smart management of the traction power and remaining energy. The principle relies on a fuel cell, which produces the electric power. It's the core of the system. The fuel cell is supplied with hydrogen on demand. By combination of hydrogen with oxygen from ambient air inside, the fuel cell produces the electric energy needed to supply the vehicle. The efficiency of the system also relies on the storage of energy in high-performance lithium-ion batteries. They accumulate the energy not immediately used in order to later supply it as needed. This results in a better efficiency of the fuel consumption. Alstom has also designed a smart power and energy management system in order to instantaneously deliver power wherever needed in the train, resulting in greater independence of the vehicle. The fuel cell is mainly used to provide traction power during the acceleration phases, with extra support from the batteries if any extra acceleration boost is required. At the same time, during the braking phases, the kinetic energy is generated by the traction inverter system, making the train nearly self-sufficient to power its onboard equipment. It's the secondary energy production. Any surplus is redirected to charge the batteries. This system has an additional consumption advantage as it saves hydrogen. During coasting or low acceleration phases, the batteries supply the energy necessary to power traction as well as onboard systems, the fuel cell remaining constantly available to recharge the batteries whenever necessary. Since the electrical energy produced by a fuel cell or recovered from braking is intelligently managed, Conradia Island matches the range and performance of similar conventional regional trains, but with nearly no impact on the environment.
So there's the question. And the answer is, today it's far too expensive because it's produced by expensive grid electricity. Before this presentation, there was that question. This really is, why is it so expensive? If we could use the energy directly from solar panels or small modular reactors, we can have cheaper hydrogen. So we could use it from that grey hydrogen I described earlier, or we could import the hydrogen from the Middle East and Africa. I think that's highly likely to happen. The Middle East, which produces vast amounts of oil that we import, as well as Africa, places like Nigeria and Algeria, they're not going to sit on their hands while their economy disappears. They're starting to install vast fields of solar capture photocells to produce the electricity to produce the hydrogen, and they will export it to us, to Europe in general, and to the United States, not as hydrogen, but in the form of ammonia, because that's easier to keep liquid. So, end of the slideshow.
Thank you, David. Can you? Yes, great. So we've got a couple of minutes just for some short questions before we go into breakout rooms to give everybody a chance to say something. Ellie?
Thank you, David, for that a very detailed description. My question is about something we saw in one of the videos. They talked about using surplus wind power when it couldn't be put into the grid to make hydrogen. The question is, how easy is it to turn that on and off?
There's an inertia, because when you've got the hydrogen having made it from the wind power, it takes a little while to actually convert that hydrogen back into electricity. It's not absolutely instantaneous. So there are issues about saving electrical energy, and there are various ways of doing it. And for example, you've got for hydroelectric power, you can have the turbines actually spinning very, very slowly, so that as soon as you want the electricity to be produced, they will do it very, very quickly. So there's a certain inertia in all the different storage systems, and hydrogen is not hydrogen has a problem. the Oxford Energy Park has about 85% lithium batteries, because the lithium batteries can deliver electricity quicker than a hydrogen system. But if you have, for example, there's a company that's using storage where they're using vanadium fuel cell batteries, they're a bit slower. So all kinds of different storage systems have a different inertia, a different speed that they can return that energy back to the grid.
Thank you. We've got quite a few hands up here, so I'll have to move through this fairly quickly. Anne-Marie?
Yeah, I just wondered, are there any specific safety concerns associated with using hydrogen, and how are they mitigated or handled?
Yes, hydrogen is very explosive, but the big advantage of hydrogen, which stops it from being explosive, if it does get out as a leak, it is so light that it actually goes vertically up into the atmosphere and disperses at actually supersonic speed. Whereas if you have petrol or diesel, petrol in particular, if that leaks, it tends to accumulate on the ground and then it forms an explosive mixture. So in theory, it's very explosive, can be quite dangerous, but in practice, it's just as dangerous as having petrol.
Heather?
Hi, yeah, bit of bad news on the Glasgow refuse trucks. Because I didn't think that project had ever happened, and it hasn't. They hoped to buy some, but they turned out there were technological and cost challenges, and so Glasgow is now buying 22 diesel buses, refuse trucks instead, at £2 million less. So I think that kind of illustrates some of the challenges at the moment with hydrogen.
Thank you for the update,
Interesting
Heather.
news. Disappointing.
Linda? Can you unmute, please, Linda?
Sorry, a year ago when the present government were talking about investing in blue hydrogen, £1 billion actually, and half that in green. I was looking at possible downsides, and there does seem to be criticism regarding the sustainability of using hydrogen due to its reliance on natural gas and the complexities of the carbon capture and storage process. You've got emissions from the extraction and transportation of natural gas, including methane leaks, and additionally, the energy intensity of the process and the potential for long-term storage issues with captured CO2 do raise concerns about its environmental impact. So I think that's the other side of the argument, David.
I think we shouldn't confuse the grey hydrogen that you're referring to from the hydrogen produced from renewable sources. There doesn't have that. And in fact, the grey hydrogen is actually the production of hydrogen from methane, fossil methane. You're absolutely right. It produces a huge amount of carbon dioxide. In fact, for every ton of hydrogen produced from methane, you get about 14 tons of carbon dioxide. If you can capture most of that carbon dioxide, then you can claim that the hydrogen is cleaner, which is why they call it blue hydrogen. But the end result we need to get towards by 2050 is to have only the green hydrogen. The process of using fossil methane has to be a stepping stone to getting to 2050.
Thank you. We've got 3 hands up and time's ticking. Steve, is yours a quick question? Is there such a thing?
Hello, David. Yeah, thanks for a presentation. I've read Chris Goodall's book, Possible Ways to Net Zero. From that, I don't get the impression, as I've got from you, that transportation is necessarily the highest priority use for hydrogen. He envisages it being largely used, stored underground as a means of storing cheap renewable energy when there's a lot of wind and solar. So could you just clarify, do you regard transportation as the main priority for hydrogen?
Well, yes, I think it is, but it's also used in, for example, producing steel. But you were referring to storage. There is an issue about storing hydrogen, but in fact, there's an issue about storing energy over a 24-hour period, because during the daytime, the renewables, particularly the wind and the sun, obviously don't shine at night. So you need to gather as much that you can get during the daytime, store it, and then use it at night time. There are certain other energy sources which are continuous, 24/7. For example, nuclear power, but there's also tidal power is continuous energy.
Thank you, David. Laurie? Yeah,
Thank you, Jenny. I came across a company about 5 years ago, a Canadian startup, which was converting diesel engines to run on liquid ammonia. And the ammonia carries 3 hydrogen rather than 2 in the hydrogen molecule. Can you make any comment on that at all for me, David?
Yes, of course. Burning anything, whether it's ammonia, whether it's a hydrocarbon, or just pure hydrogen in an internal combustion engine, excuse me, is only about 35% energy efficient. It's much more efficient to put your hydrogen through a fuel cell to produce electricity to drive the vehicle than it is to burn the hydrogen. Equally, to burn the ammonia. And yes, you can actually power an internal combustion engine with ammonia, no problem.
Thank you. Nicole, can you unmute, please?
Hi, David. Thanks. Is there any reason why the UK could not become self-sufficient in hydrogen? Why would we need to import it?
The answer to that is we're not going to be sufficient in our energy production unless we have massive amounts of nuclear power, which first of all might not be acceptable to many, but equally going to take an awful long time to build. We're going to be facing the prospect, I think, of importing large amounts of energy from the Middle East and Africa, because that represents at the moment at least 90% of our total energy demand. And to replace that in 25 years with something else is unlikely. The holy grail of energy is actually fusion power, which probably won't come available commercially for, I would say, at least 25 years, probably more.
Thank you. Ian?
I think the issue with hydrogen has been that there's always been lower cost alternatives, but I do see opportunities in heavy industry, which if they're hard to, which in their case might be hard to get to net zero. Transportation, heavy vehicles, yes, maybe. I'm not quite so sure. But also, I think there's a big option for energy storage, which I think was mentioned. We need to store energy if we're going to go to green energy. The wind's not blowing, the sun's not shining. We need to be able to store masses of energy. And I think hydrogen for energy storage around the coast, blue hydrogen from hydrolysis is a big project. And I think that would be an opportunity. So I think there are some big opportunities for hydrogen, but we have to wait and see.
I think the thing is, Ian, you're absolutely right. But the key point is you start with electricity and then you use the electricity either directly if you can connect the machine to the electric source. But if something's moving about, then you've got to convert it into something else. And for a vehicle, a small vehicle that's running around locally, pure battery power is the way to go. It's much more efficient. But if it's a big vehicle that's got to carry a lot of energy on board to go a long distance pulling a heavy load, then hydrogen and electricity is also a solution. So there's multiple solutions here.
Yeah, I agree.
Thank you. David, just to finish off, this is just a quick worry of mine. If we are buying ammonia from Africa and the Middle East, we're never ever going to be self-sufficient, are we? And are these countries then going to use these sales, in a political way to manipulate us and so on?
I think the answer to that is yes. The producers of our hydrocarbons that we import from the Middle East, from Africa and elsewhere, has a political tone to it, because they have it. Do we want it? Are we prepared to pay for it? So in the end, to have our own energy source is obviously the holy grail. And I think the answer to that is fusion energy. That is fusing, working exactly like the sun, but fusion technology has yet to be proven. We're nearly there. We probably will have the first fusion power station by around 2050, 2060, but to actually convert all our energy sources over to fusion power, or most of it, I think it's going to take at least another 100 years.
Ellie, we've overrun. It doesn't matter, but that's because everybody's so interested in this. Are we going to have 10-minute breakout rooms?
We can do sort of 5 to 10 minutes. Is everybody happy to do that? I will set them up. Let's stop the recording. So friends, as we come back in, if you write in the chat, Anne McGarry is going to have a careful eye on that and pick out any comments that are worth sharing further. While she's looking for comments, Jenny, would you like to talk for a minute on council reps?
Try again. The U3A structure changed recently, so we've now got a smaller board and council reps. And in the U3A structure, there are 9 regions and 3 countries. So Scotland, Wales, Northern Ireland, and 9 regions in England. And each of these 12 regions has got council reps, ideally 2. Some of them have only got 1. And the council reps, one of the council reps' responsibility is to feed members and U3A's priorities, you know, up so that strategy and stuff like that can be developed. And the council reps were asked earlier in the week to think about 5 priorities that they've got for the development of the organisation. And I know what's going to happen. The priorities are going to be things like, all the interest groups are full. I want to join Bridge and there isn't a group. You know, nobody will come on the committee. So, you know, I see this like important for members, but small scale in the great scheme of things. And so I was just going to say, if anybody asks you, or you can be persuaded to contact your council rep, you can find them on, find out who it is if you don't know already, on the national website. And, you know, say to them, in the great scheme of things, the U3A needs to get ahead of the game and, you know, make environmental and climate concerns on that agenda and use U3A members. I mean, there's over 400,000 of us. Use U3A members' purchasing power, you know, in the supermarkets, in the banks, with insurance and stuff like that. Use U3A members' voice to really push this climate agenda so that the U3A doesn't fade into the background because there aren't enough people willing to run the table tennis group. But, you know, we have an important voice out there for thinking about, you know, the future of the country, the world, for our grandkids, for everybody else. So please, if you can, contact your council rep, tell them you want the U3A to be much more involved with climate and environment issues, please.
Thank you, Jenny. Anne McGarry, is there anything there that you need to bring to our attention?
You're muted, Anne.
Well behaved. It was mentioned that JCB and Utoxeter are developing a fleet of hydrogen vehicles, but don't know what sort of hydrogen they're looking at. Could cargo ships be a good things to use hydrogen on? Someone wondered if there was any lobbying to redirect investment from carbon capture to hydrogen. And then there's a comment about, is it possible to charge electric vehicles along roads, as they think is being done in Sweden?
Yeah.
Alternative to hydrogen for long distance vehicles.
I answer some of those questions.
Yeah.
Okay, first of all, JCB tried to have fuel cell powered earth movers and diggers and that kind of thing. And they found that the problem is that the shock loading of those vehicles when they're actually operating shakes the fuel cell to bits. So they abandoned the idea of using fuel cells. So what they then decided to do was to have internal combustion engines. And they have developed a very, very efficient, energy efficient internal combustion engines that burns hydrogen. But this is a compromise because burning hydrogen when you don't have to is a bad idea. If you have a heavy earth moving machine which has got lots of shock loading, then that's the way they've had to go. What was the other question? There was another one about...
Oh, possibility about cargo ships?
Yes, absolutely, except probably cargo ships where there are very few people, it will be transported as ammonia, because transporting hydrogen, if you want to make it a liquid, which would be an efficient way of doing it, you've got to actually reduce it to less than minus 256 degrees Celsius, which requires a lot of energy. So the best way, and that's probably the way that hydrogen is going to be imported from the Middle East and Africa to Europe and to the United States, will be imported as ammonia. Because ammonia, when it arrives at the shores, can be very easily split with a simple catalyst into nitrogen, which goes into the air, and just the hydrogen.
Thank you, David. I'm going to stop it there because we are at time now. That's been a fascinating talk. Thank you very much indeed. Brilliant ideas in the chat. If you would like to capture those, you can save the chat now while you're still on the call. We've had a new idea, and I'll run it past you, for a tip of the month. This is to come from members. So if anybody has a good idea, contact us and we can give you the tip of the month slot. This month's idea is called Beef It Down. And if you have friends who still want to eat beef, we know that stopping eating beef is one of the best things you could do for the environment. But there's people that you know or love, or you yourself, who want to still eat beef. What about suggesting just reducing the amount they eat? So if they have beef every week, have it as a treat every other week, and you've halved your consumption. So there's just an idea for the month. Our next meeting is on the 27th of June, and we'll put out all of the details, including the topic nearer the time. And I don't know if any of you are going to have a party on the 16th of June, but it's Clean Air Day. Okay, friends. I will see you all next time. I'm going to stop the recording and close the meeting now. Would the core group like to just stay on for a quick debrief?